You know, one of the nicest things in the world is to go outside on a summer evening and watch the moon rise. And when you see it come up over the horizon, it looks absolutely enormous, just huge, like you could reach out and touch it. And then, a few hours later, you look up, and there it is, way up high in the sky, and it looks small, normal, like a moon should look. And you think to yourself, that's funny. So you go get a camera, or you hold up your thumb, or you take a coin and hold it at arm's length and you measure it. And here's the crazy thing, it's exactly the same size. Exactly. The moon hasn't changed size at all. It's the same angular size in the sky, whether it's on the horizon or straight overhead. So what's going on? Is your brain playing tricks on you? Well, yes, that's exactly what's happening. And this isn't some new discovery. This has been driving people crazy for thousands of years. Aristotle noticed it in the 4th century BC. Ibn al-Haytham, this brilliant Arab scientist about 1,000 years ago, he worked on it. And you know what? We still don't have it completely figured out. Now, let me tell you what's not causing it, because that's important. A lot of people think, oh, well, maybe the atmosphere is acting like a lens, magnifying the moon when it's down low on the horizon. That's a very reasonable guess. But it's wrong. The atmosphere does do something to the moon when it's near the horizon, but it actually makes it very slightly smaller, not bigger, and it makes it more orange or reddish because the light has to travel through more air, and the air scatters away the blue light. But magnification? No. And some people think, well, maybe the moon is actually closer to us when it's on the horizon, but that's backwards too. When the moon is on the horizon, you're looking at it across the radius of the Earth. So it's actually about 4,000 miles farther away than when it's overhead. That makes it very slightly smaller, about 1.5%. So that's not it either. So what is it? Well, it's all happening in here in your brain. This is what we call a perceptual illusion. Your brain is doing something very interesting with the information it's getting from your eyes. Now, let me show you something. Imagine you're standing on some railroad tracks, looking down them into the distance. The tracks are parallel, right? But they look like they're getting closer together as they go away from you. They appear to meet at a point way off in the distance. We call that the vanishing point. This is called perspective, and it's how your brain understands three-dimensional space when it's looking at a flat image on your retina. Now, suppose I draw two horizontal lines across those railroad tracks, one near you and one far away. Both lines are exactly the same length, but the one far away, where the tracks are closer together, looks longer. Your brain says, well, if those two lines make the same angle in my eye, but one is farther away, then that far one must be physically bigger. That makes sense for most objects in the world. If something far away looks the same size as something nearby, it probably is bigger. This is called the Ponzo illusion, named after an Italian psychologist, Mario Ponzo, who studied it in the early 1900s. And many people think this is a big part of what's happening with the moon. When the moon is near the horizon, you see it with all this foreground stuff, trees, buildings, hills, the terrain stretching away into the distance. All of these things are giving your brain distance cues. They're like those railroad tracks. Your brain is going, okay, I'm looking at something far away here. But the moon's image on your retina hasn't changed size. So your brain does its calculation. If this thing looks the same size in my eye, but it's far away, it must be huge. And so you perceive it as huge. But when the moon is high overhead, there's nothing around it. No trees, no buildings, no distance cues, just empty sky. So your brain thinks it's closer and therefore smaller. Now here's where it gets really interesting. Most people, when you ask them, they'll tell you the horizon moon looks bigger and closer, not farther away. About 90% of people say this, which seems to contradict what I just told you. But here's the thing. Your conscious perception and your unconscious visual processing aren't always the same thing. Deep down, your visual system is treating that horizon moon as if it's farther away, even if you consciously think it looks close enough to touch. There's another part to this, and it has to do with how we perceive the shape of the sky. Now, if you ask someone, what shape is the sky? They might say, it's a dome, half of a sphere. But we don't actually see it that way. If you really pay attention to how the sky feels, it's more like a flattened dome, like an upside-down soup bowl. The horizon seems much farther away than the point straight overhead. Why do we see it this way? Well, think about it. When you look at birds flying or airplanes or clouds, The ones overhead really are closer than the ones on the horizon. You've spent your whole life learning that things straight up are close and things near the horizon are far away. So your brain has built up this model of space, this flattened dome. And when the moon is projected onto this mental model, at the horizon it's on the far away part of the dome, so it gets scaled up. When it's overhead, it's on the close part, so it looks smaller. Same actual size in your eye, different perceived size in your brain. Now, I should tell you, not everyone agrees on this explanation. Some experiments have tested whether people really perceive the sky as a flattened dome, and the results are mixed. Some studies say yes, others say no, and when you dig into the details, it gets complicated. There are probably multiple things happening at once. For instance, there's also something about the way your eyes focus on distant versus nearby objects. And there's the fact that when you look up, you're tilting your head back, and maybe that changes something about how your visual system works. Here's a fun thing you can do. Next time you see a huge moon on the horizon, bend over and look at it upside down between your legs. I know you'll look ridiculous, but try it. The moon will suddenly look normal-sized again. Why? Because you've disrupted all those distance cues. Your brain can't use its normal perspective tricks when you're looking at the world upside down. Or you can look at the moon through a paper towel tube. Same thing. You block out all the foreground objects, and suddenly the illusion disappears. The moon looks the same size it does overhead. And here's another peculiar thing. Astronauts in orbit see the moon illusion too, even though they don't have trees or buildings or any foreground objects. So maybe the foreground explanation isn't the whole story. Maybe it's more about the angle of regard, or how we're orienting ourselves in space. You see, this is what makes the moon illusion so fascinating and so frustrating. It's been studied for over 2,000 years, and we still don't have one single explanation that everyone agrees on. Different researchers emphasize different parts. The Ponzo effect, the flattened sky dome, the foreground objects, the angle of viewing, even the curvature of clouds in the sky that we've been looking at since we were babies. The truth is probably some combination of all of these things. Your brain is incredibly sophisticated. It's taking in all this visual information and trying to construct a three-dimensional world from a two-dimensional image on your retina. Most of the time, it does an amazing job. But sometimes, in unusual situations like looking at the moon, it makes mistakes. It applies rules that work great for nearby objects, but don't work for something that's, 250,000 miles away. And that's the beautiful thing about studying perception. We think we just see the world directly as it is, but we don't. We construct it. Our brains are doing all this incredible processing, making assumptions, filling in gaps, using what we've learned from a lifetime of experience. And usually it's so automatic we don't even notice. But then something like the moon illusion comes along and shows us, hey, there's a lot going on under the hood here. The moon's angular size in the sky is about 0.5 degrees, whether it's on the horizon or overhead. You can measure it, it's a fact. But you cannot make yourself see it that way when it's rising. Even though I understand all of this, even though I know the moon illusion is an illusion, when I see that giant moon on the horizon, it still looks huge to me. My conscious knowledge can't override what my visual system is doing. And that tells you something profound about how the mind works. Perception isn't just about the signals coming into your eyes. It's about how your brain interprets those signals based on context, based on experience, based on models of the world that you've built up over your entire life. So the next time you see a big, beautiful moon rising on the horizon, yes, enjoy it. It's gorgeous. But also appreciate that you're witnessing your own brain in action, doing something fantastically complex and creative, and sometimes getting it wonderfully wrong. That's not a bug, that's a feature. That's your brain being smart, using all its tricks to make sense of the world, even when those tricks occasionally fool you. And maybe someday someone will figure out the complete explanation. Or maybe not. Maybe it's one of those things that's just too complicated, with too many factors interacting. But that's okay. We've learned a tremendous amount just from trying to figure it out. We've learned about how the visual system works, how the brain processes depth and distance, how context affects perception. And that's worth something even if we never get the complete answer. Because science isn't just about having all the answers. It's about asking good questions and being honest about what we know and what we don't know. And the moon illusion, after thousands of years, it's still asking us questions.